Hello, I'm Seema and welcome to part 31 of the chapter Hydrocarbons. We were solving the exercise questions of ozonolysis of alkenes. That is, we did question 13.4 in the previous part. In this video, we are going to move ahead with the same solving of exercise questions. Question 13.5, 13.6 and 13.7 are either reverse questions or they are questions with where a little trick has been put in. In the previous video when we did question 13.4, we were given 4 compounds whose products on ozonolysis were expected from us. So we carried out the whole reaction of the process of ozonolysis and we got the compounds, that is the products. In this question, this is a reverse question, question 13.5. Let me just read the question. An alkene, the name of the alkene is not given. In the previous question, the name of the reactant, that is the alkene, was given. Here, you're not given the name of the alkene. And alkene A on ozonolysis gives a mixture of ethanol and pentanol, pentane 3-O. So the products are given to you. You are expected to find out. These are the products of ozonolysis of an alkene, and the alkene is represented by A. So you have to identify A and give the IUPAC name of this compound. So it is basically the same question, only now instead of going from the beginning to the end, we are going to start from the end towards the beginning of the reaction. We are given the products of ozonolysis. So we'll first write down the structures of the products of ozonolysis. Then at those 2 points, there will be 2 carbons which will have double bonds with oxygen. In both the products, there will be 1 carbon each which has a double bond with oxygen. We will write the products in such a way that the 2 carbons with the 2 oxygens come close together so that we get the ozonide structure from it. And then from that, if we remove the ozone, you can get the structure of the original alkene. So that is what we are going to do here. So what are the products? The products are ethanol and pentane 3-O. Ethanol is CH3 CHO. Alright, this is ethanol. And if I try to draw the structure of the double bond with O, I will write CH double bond O. Because I want to always be sure where the double bond O is, because I would like to put the 2 carbons with the double bond O adjacent to each other in order to get the ozonide. And the second is pentane 3-O. So pentane CH3 CH2 C. Here there's the third carbon has the bond with oxygen, pentane 3-O. So it is CH2 and CH3. Yeah. So this is pentane 3-O. Now, in order to write down the product, these are the 2 products, right? These 2 are formed as a result of ozonolysis. For these, what would be the ozonide from which they have been formed? In order to write down the ozonide, I'll write the structures in such a way that the oxygens, the carbons bearing the oxygen, they come together. So I write CH3 CH double bond O. So this is here. But for this compound, the oxygen should come here and the carbon should come here. The oxygen and carbon should come closer. And I mean closer to this compound. Let me write it a little closer. So oxygen is here and the double bond and carbon should come here. So the rest you can write CH2, CH3, CH2, CH3. Do you see? All I have done is change the orientation in such a way that both the carbons which have the double bond with oxygen, they are adjacent. Now, in the next step, these are the 2 products. If I remove the 2 oxygens, if I remove these 2 oxygens, let me write this down again just to show you how we'd be doing the steps. CH3, CH, and there was a double bond here. Instead of writing the oxygens, I leave the space here and write C, CH2, CH3, CH2, CH3. Between these 2 carbons now, I put a double bond. The 2 carbons which were forming double bonds with oxygen, now instead of writing oxygen here, I just put a double bond between the two, and that gives me the original alkene. So this is compound A. And you're supposed to write down the structure. We've already written down the structure and the IUPAC name of A. What will be the IUPAC name of this compound? Now, this will be treated as a branch, and this is your main compound. Alright, so 1, 2, 3, 4, 5. There are 5 carbons. It is pentene. And the ethyl group here is attached to the third carbon. So what will be the name of this compound? It will be 3-ethyl pent, and the ene is on which carbon? On the second carbon. So it will be pent 2-ene. 3-ethyl pent 2-ene will be the name of the compound. So now we'll do problem 13.6. Give me a moment to write it down. Now this question 13.7, is similar to question 13.5. So before I do question 13.6, I'd like to do question 13.7 because it's almost the same question. Let's read the question. Propanol and pentane-3-one are the ozonolysis products of an alkene. You have to identify what is the structural formula of the alkene. In this, you were expected to write down the IUPAC name of the alkene. But in this question, you're not even required to do that. You just need to reach this spot. That you have to tell what is the structural, draw the structural formula of the alkene. You've been given the two products of ozonolysis. So we'll do the same thing as we did here. We'll write down the two products. The first is propanol. Propanol would be CH3 CH2 CH double bond O, right? This is propanol. And pentane-3-one, CH3, we had pentane-3-one here also, CH2 C double bond O, CH2 and CH3. Now, just as we did in this problem, I would like both the carbons which have the double bonds with oxygen to be adjacent, because that is where that is what will give me the ozonide, and that is where I will be drawing the structure of the that is how I will be making the structure of the alkene. In this question also, if I wanted, like when I put the two adjacent here, I could have removed these two oxygens and I could have put a double bond here, no, not a double bond. I could have made an oxygen here and an oxygen here and connected it to this. This would have formed the ozonide. And if you remove the oxygens and make a double bond instead, you would get the final product. This would be the structure of the ozonide, that is the intermediate. So we can do the same thing here. If we put the two carbons having the oxygens adjacent to each other, we could make the structure of the ozonide. So I'll write CH3, CH2, CHO and CO. This goes up, CH2, CH3, so that it doesn't come in the way, and this remains as such, CH2, CH3. If I want to draw the ozonide, it is possible to do it just by removing the two oxygens, and between these two carbon atoms, if I make an oxygen here, an oxygen here, an oxygen here, and these are connected, this is the intermediate ozonide. And this ozonide was created from what? This is the final product. The final product with zinc and water. This is the ozonide which was prepared by the ozonolysis, or the reaction of the alkene with ozone. So add ozone. So what is the alkene? Again, make the same structure, write down the same structure, and now instead of these oxygens, just put a double bond between these two carbon atoms. That will be the original alkene. So I'll write CH3, CH2, CH, double bond, C, CH2, CH3, CH2 and CH3. You know, normally when we put an ethyl group as a substituent, we can write it as CH3, CH2, CH, double bond C. It can be written as C2H5 also. CH2 and CH3. This is the structure, this is the detailed structural formula, and this is a little compact where the ethyl group has been compacted together. So this is the structural formula of the alkene from which these products were obtained. And this alkene must have reacted with ozone to give you this ozonide. With the ozonide then with reaction with zinc and water would have given you these two products. And now we'll come to question 13.6. Give me a moment. So let us now do question 13.6. This question is really interesting. An alkene A contains, they've not given you the products. They've not given you the alkene. They've just given you hints on what the alkene may be like and hints about the products. And you have to derive both the alkene and the products from the hints that you have got. An alkene A contains 3 carbon-carbon and 8 carbon-hydrogen sigma bonds. There are 3 carbon-carbon single bonds and there are 8 carbon-hydrogen single bonds, that is sigma bonds, and 1 CC pi bond, which means it is an alkene. An alkene can only be an alkene when at least there is 1 double bond in the compound between 2 carbon atoms, and that the 2 carbon atoms, that second bond is a pi bond. So it has 1 pi bond, which means obviously that A is an alkene, right? Then the second thing he says is that A on ozonolysis, when you carry out the ozonolysis of A, it gives 2 moles of an aldehyde. It gives 2 moles of an aldehyde. What have we seen? We have seen that if there is an alkene, let us say X, C, double bond, C, X. Okay, or Y. I should not say X, I should say Y. Okay, there is an alkene, and when you react, when you carry out the ozonolysis, O3, it will give you the ozonide, and the products that the ozonide would be C, O, C, O, O, and X and Y, which will break down, and in the next step with zinc and water, what will it give you? Zinc plus water, it will give you X, C double bond O, and Y, C double bond O, right? Whatever the products are, this is how you would get the products. Whatever X is, whatever Y is, remains the same. The only change that is going to take place is between the double bond and oxygen adding to it, then the breaking of the oxygen of the ozonide to give double bonds with oxygens. As I explained in the previous video, when for this carbon, it is bound to this oxygen here and this oxygen here. When this bond here breaks, the oxygen gets back its electron. And when the bond between carbon and oxygen breaks, carbon gets back its electron, oxygen gets back its electron. So what happens? Now carbon has an electron, oxygen has an electron. They share that electron and form the double bond. The same thing happens on this side also, and that is why you get these products. Now let us come to the question. Back to question. We have just revised what ozonolysis reaction would be like. He says that we should be getting 2 products. Do you see here? We should be getting these 2 different products, XC double bond O and YC double bond O. But what does he say in the question? That it gives 2 moles of an aldehyde. 2 moles of an aldehyde. What is the formula? What is the functional group of an aldehyde? CHO. It gives you 2 moles of an aldehyde, which means that whatever this is, CH, if this is CH here and this is CH here, then Y is also identical to X because it is giving us 2 moles. Both of these should be the same product. That is only possible if on both the sides you have the same thing. So here you will have H, here you will have H, CHO and CHO. XCHO, this Y will also become X. If it is X, this is also X then. And if this is also X, you are getting 2 moles of XCHO. So whatever X is on both the sides of the double bond, the carbons, both the sides have the same composition. That is why you are getting 2 moles of the product. So an alkene A, now we'll say an alkene A contains 3 CC bonds. If there are 3 carbon-carbon bonds, let us make a chain of carbons now. One carbon I write here. What happens to the pen? I don't know initially. And then it starts writing. Carbon, yeah. Carbon, carbon. These are only 2 bonds. It said there are 3 carbon-carbon single bonds, which means there are 4 carbons. Right? There are 4 carbon atoms and 4 carbons, and there are 8 carbon hydrogen atoms. Also it says that there is an alkene and that the aldehydes that are formed are the same, which means whatever the structure is, the double bond should be in the center. So the double bond is here because it should be symmetrical. On this side of the double bond you have 2 carbons, and on this side of the double bond you have 2 carbon atoms. Let us fill this up with hydrogens. This will have 3 hydrogens, 1, 2, 3. This is forming 3 bonds, so it will have 1 hydrogen, forming 3 bonds, so it will have 1 hydrogen, and this will also have 3 hydrogens. Count the hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. How many hydrogens are there? 8 carbon hydrogen bonds. And now let us carry out the ozonolysis of this compound. If you carry out the ozonolysis of this O3, what will you get? You will get, let me put the arrow here because I always write down the product in the bottom. If I make the ozonide here, I'll concise this now. I wrote them separately so that we could have counted them. So you have CH3, CH, CH, CH3. These 2 carbons, you'll form the ozonide here, right? You get the ozonide, which in the next step with zinc and H2O will give you CH3, CHO plus. This will also give you CH3, CHO. Or in other words, instead of writing it like this, we'll write that this gives us 2 CH3 CHO. Does it satisfy all our needs here? All the hints that were given to us? That there are 3 carbon-carbon single bonds, which means there were 4 carbons. 8 carbon-hydrogen bonds, we have seen that if it's an alkene. 1 carbon-carbon pi bond in such a way that the product that you get is identical. You get 2 moles of the same compound, which means you're getting 2 moles of the same compound, and the compound is an aldehyde. So we get 2 moles of this aldehyde. What is this aldehyde? It is ethanol. Let us now calculate the mass of ethanol, because it says the aldehyde has a molar mass of 44 unified units. So the mass of carbon is 12, right? The mass of carbon is 12 plus, there are how many hydrogens here? 4 hydrogens in this. So 12, 1 into 12 plus, 2 into 12. There are 2 carbons here. And 4 hydrogens plus 4 into 1 plus 16 into 1, because there is 1 oxygen. So 12 twos are 24 plus 4 plus 16, 20 plus 24 will be 44. 44 U's, or atomic mass units, which is also right according to this. So you see, it's basically the same question. Once you have understood ozonolysis, the question may be twisted or made. Take it as a game, have fun when you're solving it, and then the problems do not seem problems. You'll start enjoying solving questions, and then of course, if you start enjoying it, you really score well in your exams. So with this, I'll wind up this video. In the next video, we are going to start with alkynes, I guess. Addition of water, yes. In the next video, we are going to start with alkynes. So if you found this video helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and if you want to watch the other videos of this chapter, click the link that appears on the top of your video, and keep returning for more videos in chemistry. Thank you for watching. Bye bye for now.